Hey, what's going on, fellas? What we're looking at here is a Lincoln Electric Handy MIG. And the topic of this video is MIG welder and flux core welder wire feed. I learned something today the hard way. And as it usually goes, we learn the most in the midst of mistakes we make. So, because I am not a welder by trade, I did not realize that there's something going on here with this little wheel. This welder worked fine for 4 spools of wire, and then I noticed it wasn't feeding right. I was having trouble getting it to weld. You can see here, I just wasn't getting a consistent bead. No matter what I did, it was just acting up on me, and I didn't know what was going on. You can see here in spots like this, when it is working right, it gives you a great bead. But come to find out, guys, this wheel is adjustable. You take this out. I did not know this and I feel so stupid. This wheel is double-sided, fellas. The machine comes set to 0.9. As you can see right here, they're indicating the wire the device was shipped with, which is the 0.35 for flux core. So, in the midst of me changing things up, I have converted over to 0.30 wire. And over time, over 4 spools of wire, it started acting up a little bit. And I think the main reason being is I should have been running it on the 0.6 side. So you have to flip this wheel over. I didn't know this. I'm a complete idiot. A lot of you welders know this. I have not seen a video yet talking about this wheel. This is very important. So, because I ran out of wire jacking around, one of the things also is that these spools, some of these spools are kind of crappy. So be careful what kind of wire you get. If they don't spin just perfect, if there's any type of catch in the spin, like if you come to a catch, it spins loose, then all of a sudden it catches a little bit, that turns up in your weld. And some of these Lincoln wire spools will do that. They're a little too tight right there. As I said, I will post a link in the description for this welder so you can check the prices on these things and compare. And if you do decide to go for one of the Harbor Freight models or one of the cheapo units, make sure it's not an AC unit, guys. And if you click the link in the description, it'll take you to all different types of welders. And if you do want one of the cheapest AC ones, this link will take you to that. I'm not proposing you buy just a Lincoln. The link I'm going to give you is going to take you to some Amazon welders. But for the most part, be on the lookout for this. You want a polarized machine, a DC machine. A lot of the people going out and buying them Harbor Freight welders don't realize that those Harbor Freight flux core welders are AC machines. So don't do it, guys. I'm going to crack this thing open. We're going to take a look inside of it also. And yeah, that's just the thing about AC is that let me draw a little example of what happens, of why you don't want an AC flux core welder. There are guys who posted some videos that shows what the welds look like, but basically this is what's going on with a DC machine. Let's pretend this is the wire right here. With a DC machine, the electrons are flying out of the gun in this direction and hitting the work. This point of the work is going to get the hottest because you have electron impact. That gives us the penetration that we need for a good deep weld. Now when it's working in the opposite direction, when the electrons are flowing from the work to the tip, all your heat's right here on the tip, and it literally turns that flux core into an explosive, and it just splatters the tip to bits, and you'll have massive piles of splatter, not to mention nowhere near the penetration. So AC machines cannot weld deep. They're junk. They're kind of like a Solaris air conditioner, so to say. Just a scam product that appears to be a welder, you know, and to the average Joe, it'll probably do just fine around the house. Or you want to weld a crack on your lawnmower deck or something like that. Something just completely you know, non-consequential, then yeah, but that's the reason, guys, why you can't buy a crappy Harbor Freight AC welder, because you want those electrons hitting the work, giving you that penetration. Now, if you're going to weld some sheet metal and you don't want to burn through, they give you that option to change this over. That's why this is here. So if you're going to weld extremely thin materials, then you're able to do that. And then again, back to the AC thing, with let's say this is your DC penetration and this is your AC penetration. With the polarity changed, you can get an even lower penetration, because AC is going to be giving you some of both worlds. Maybe it's halfway, we'll say, but with the polarity change, you can get even less penetration than you can with an AC machine, which if you're doing auto body and things like that, I would imagine you guys are probably running with your electrode positive, even though there's some more splatter involved. I don't know for sure. I don't do auto body, but I do know in stick welding, I often run electrode positive to minimize penetration when I'm working. Okay, so here we are, fellas, inside a Lincoln Electric Handy MIG. Fairly robust looking design here. I like what I'm seeing. What we have here is a big diode. Is that right there? I'm not sure if that's a full wave or not. It doesn't look like a full wave rectifier to me. I'll have to look into that. It does have a fairly robust transformer, which appears to have a center tap, which is what all these switches are about. They're center tapping the voltage. This large item here is an inductor, and this is hooked directly in series with the welder itself. Man, that's a really stiff wire right there too. Massive conductor. I kind of like that. The reason they use this is to mitigate something called harmonic distortion of current, which is caused by high amperage transformers. They put off so much magnetic fields that as one field's collapsing, electricity is trying to travel through another wire, and a counter electromotive force is induced. So this mitigates that and enables the DC transformer or the DC current output to be higher, because capacitors alone won't do it. When you have a DC system of this much current, you have to use an inductor. These are also called chokes. As far as the fan setup, I kind of like what I'm seeing there also. They have this configured where the air is blown directly out of the back of the unit versus just blowing hot air all over the place. And what I'm seeing here is it appears the cool incoming air comes up from the bottom over the diode, which is what we want to see. We want this getting cooled first, and then the air is brought back over the transformer here. There's a very small motor running that driver, which concerns me. You want a lot of power in your driver, because we all know how these wheels can click up. They act a little funny. They're not consistent in the way they spin sometimes, and that's going to show up in your weld. So if you're looking to do really nice welds, that may not be a possibility with a motor that small. I'm not a good enough welder to know if I just suck at it so bad I'll never have good welds, or if it's the junk machines that I'm using that are causing the welds to be poor quality. I do kind of like what I'm seeing here. This is a very good wire, thick, high amperage wire, really nice looking diode. I'm not sure what I think about this size of the vent here. I'd almost want forced air directly on my diode personally, but that's just how I am. I mean, that's part of the duty cycle rating of this thing, I would imagine. Another thing that limits the duty cycle in this is going to be the tip, of course, of this rather feeble gun. It's not quite that great. But as far as duty cycle, I have never had this thing, the thermal trip, shut down on me. And I have welded together some extremely large items. You see the beads I was running here. Never once did this welder shut down during the fabrication of this heater. So definitely happy with the buy. I'm glad I figured out this issue with the wire feed, because I'm a total idiot, guys. I'm not a welder. I didn't know that this wire feed, this little wheel right here, can be adjusted. If you change wire from 0.035 or 35 thousandths of an inch, you have to take this wheel out and flip it over to the 0.06 or the 0.6 millimeter side. I didn't know that. The thing wasn't feeding right. Here I am blaming Lincoln, and I'm just an idiot all along. So there you have it. If anyone wanted to see the inside of one of these things, it is fairly well made. I am pleased with the transformers. Really nice looking transformers. And I like the design of this too. Notice the secondary is wrapped around the primary, guys. I don't know, this doesn't have the same design we're used to seeing, the secondary on top and the primary on bottom. If there's any electrical engineers out there who know what's going on here, let me know. That's kind of an interesting choice they have there. The secondary wraps around the primary. I didn't know that was even feasible. You would think that would affect the AC current in some way.